Hi, this is Leetcode question. Maximum twin sum of a linked list. For this linked list, this node is twin with this node. The sum for this twin is 5 plus 1 equals 6. And this node is twin with this node. The sum for this twin is 6, and the maximum is 6. For this linked list, this node is twin with this node, and the sum for this twin is 7. This node is twin with this node, and the sum is 4. The maximum is 7, so we return 7. Solve this question. First of all, let's solve it with a trivial solution by iterating over all the nodes in the list and fill their values into a vector. So the value vector at the end contains all the linked list value 2, 4, 7, 3, and now it's easy to access the indexes in the vector, and we iterate until n divided by 2 minus 1, and with every iteration we calculate sum for the twin. So I at 0, this is the first twin, the sum is 8, and for this I equal 1. This is the next twin, and the sum is 8. The third twin is this one, the sum is 6, and the maximum is 8, so the answer is 8. The space complexity for this is big O of n. Now let's solve it without extra space. What we need to do is to reverse the second half of the linked list. So here we have two pointers. The first pointer is pointing at the head, it's pointer 1, and this is also pointer 2. Now in the first loop we need to count the number of the nodes in the list so that we know where is the middle of the linked list. So by the end of this loop, n will be the number of nodes, which is 1, 2, 3, 4, 5, 6 nodes, and pointer will be at the end, so that here we reset it back to point to the head. Now we know n equal 6, so we need to move the second pointer to the middle, or the node that is previous to the middle of the linked list, and this is what we are doing in this loop. We start from I equals 0 until I less than n divided by 2 minus 1, and this will move the pointer to point to this node, because this is the middle and this is the node that is before the middle. And then we reverse the linked list and we pass to it pointer 2 of next, so we pass to the function of reverse pointer 2 of next. Pointer 2 of next is this node, which is the middle of the linked list. So this function here will take the linked list 4, 7, and 3, and 3, this is null pointer here, and we'll do the reverse of linked lists. So after reversing this linked list, of course we are doing the reverse using these two pointers, next and previous, and we swap the pointer at each stage. This is Babylon algorithm to reverse any linked list, and at the end we need to return the previous. So after finish this function, we return a pointer which is previous, that points to the linked list which is reversed. So 3 points to 7, points to 4, 4 points to null pointer, and we assign this return value to pointer 2 of next. So pointer 2 is this one, we assign to it this return linked list. So the returned linked list is a 3, 7, and 4. This is the end of the linked list. Now this linked list here becomes our new linked list. What we need to do is now we move the pointer to the middle, to exactly the middle of the linked list. So this is the pointer 2, we move it to the middle. This is the middle, pointer 2. Let's rewrite the linked list again. So we have 5, 1, 2, 3, 7, then we have 4. So pointer 2, we said we move it to the middle, or to the next of the current one, which is exactly the middle. So this is pointer 2, and pointer 1 is at the beginning. Now at every iteration we calculate the sum of the twin. So pointer 1, pointer 2 form the twin, and the sum of the values here are 5 plus 3 equal 8. And then we move two pointers. So pointer 1 comes here, and pointer 2 comes to the next node. Now the new twin is 1 and 7. 1 plus 7 equal 8. Then again we move pointer 1 to the next node, pointer 2 to the next node. The new twins is 2 and 4. 2 plus 4 equal 6. Then we move again pointer 1 to the next node, and pointer 2 to the next node, which is null. Now pointer 2 is null, so this condition break, and the maximum among all of these values is 8. So the answer for this linked list is 8.